In the silent depths of the ocean, where sunlight fades into shadow, a mysterious creature glides with otherworldly grace. This is the jellyfish, an organism so delicate that it seems woven from water and light. Belonging to the phylum Cnidaria, jellyfish have no brain, no heart, and no bones. Yet they have survived on Earth for over 500 million years, predating even the dinosaurs. Their bodies are composed of more than 95% water, giving them a transparent, gelatinous appearance that floats like a ghost in the current. Despite lacking a central nervous system, jellyfish possess a simple but efficient nerve net. This decentralized system allows them to detect stimuli such as changes in light, water currents, and the presence of prey. When a small fish or plankton brushes against their trailing tentacles, specialized cells called cnidocytes react instantly. These cells unleash microscopic harpoons filled with venom, paralyzing the target in milliseconds. In the abyssal zones of the deep sea, where darkness is absolute, some species of jellyfish perform a haunting display of bioluminescence. Through a chemical reaction inside their bodies, they emit a cold, glowing light. This luminous performance can confuse predators, attract mates, or lure prey. It is a light show evolved not for beauty but survival in one of Earth's most extreme environments. Among all jellyfish, one species challenges our understanding of life itself. Turritopsis dohrnii, often called the immortal jellyfish, holds a remarkable secret. When faced with injury or aging, it can reverse its life cycle, transforming its adult cells back into a younger polyp stage. This ability, known as transdifferentiation, allows it to essentially start life over again, potentially evading death altogether. Scientists around the world are studying this tiny creature, hoping to unlock clues about cellular regeneration and the aging process. In the grand theater of evolution, the jellyfish is a quiet but profound player. It speaks not with sound but with movement, light, and the intricate language of biology. In its simple structure lies a deep complexity, one that continues to inspire awe and scientific inquiry. Beneath the rolling waves of our planet's oceans, an ancient balance unfolds, a delicate web of life where every creature plays a role. Among these silent actors, the jellyfish floats as both predator and prey, a drifting enigma in the vast marine ecosystem. Though seemingly fragile, its presence is a cornerstone in the underwater food chain. Jellyfish consume vast quantities of plankton, small drifting organisms that form the base of oceanic nutrition. With their trailing tentacles and rhythmic pulsations, they sweep through the water, filtering microscopic prey with quiet efficiency. Yet the jellyfish is not merely a consumer. It is also consumed. Its soft bell and gelatinous body make it a vital food source for a variety of marine species. Sea turtles rely heavily on jellyfish, especially the leatherback turtle, which travels thousands of kilometers to feed on them. Small fish, crustaceans, and even seabirds have evolved techniques to feed on jellyfish without falling victim to their stinging cells. In this way, the jellyfish bridges the microscopic world of plankton and the larger hunters of the deep, serving as a vital intermediary in oceanic life. But this balance is fragile. In recent years, scientists have observed alarming blooms of jellyfish, sudden and massive increases in their populations. These blooms can devastate local ecosystems. Swarms of jellyfish consume the eggs and larvae of commercial fish species, threatening fisheries and food security. Their tentacles clog fishing nets, damage equipment, and disrupt coastal tourism with their stings. Entire power plants have even been forced to shut down when jellyfish clogged their intake systems. What was once a natural part of the marine web can, under certain conditions, become a force of ecological disruption. The causes of these blooms are complex, but many point toward human influence. Climate change warms the oceans, creating ideal breeding conditions for jellyfish. Overfishing removes their natural predators and competitors, while nutrient pollution from agriculture creates dead zones where jellyfish thrive and others cannot. Ocean acidification, another consequence of rising carbon dioxide levels, appears to favor the soft-bodied jellyfish over shelled creatures that struggle to build their calcium homes. In this shifting seascape, jellyfish are no longer just survivors. They are indicators. Their increasing presence signals that something fundamental is changing in our oceans. They glide through the tides like translucent messengers from a world we barely understand, a warning that the balance we once knew is drifting out of reach. Across the cultures of the world, from the ancient harbors of the East to the galleries of the West, the jellyfish has long captured the human imagination. Its ethereal form, suspended in the ocean like a living dream, has inspired artists, dancers, and storytellers alike. With no bones and no face, it moves in silence, yet speaks to us through beauty, mystery, and the rhythm of its flow. In Japan, the jellyfish is more than a marine creature, it is a muse. Aquariums host mesmerizing jellyfish exhibits, illuminated in soft blues and purples, creating spaces that blur the line between nature and art. Entire art installations are dedicated to capturing their gentle pulsing, their ghost-like drift, and their delicate yet dangerous elegance. Visitors often describe these experiences as meditative encounters, a journey into another realm. In the town of Como, the annual jellyfish display at the Como Aquarium draws thousands who come not only to observe but to reflect on the wonder of these translucent beings. In Korea, the jellyfish has become a symbol of movement and light. Choreographers have studied its graceful locomotion to inspire contemporary dance performances, while lighting designers mimic its glow in stage productions and art shows. The way a jellyfish drifts and spirals through water has been translated into human movement, expressing themes of fragility, transformation, and time. Even in modern fashion and digital design, jellyfish patterns appear often in swirling fabrics, holographic textures, and soft neon colors. Western media, too, has embraced the jellyfish as a symbol of the surreal. In animated films and science fiction, jellyfish often appear as creatures from other dimensions, drifting through alien oceans or glowing in the dark skies of imagined planets. Sometimes they are gentle spirits, other times they are harbingers of danger, embodying the tension between beauty and threat. Their form is so unlike any land animal that they become a perfect vessel for storytelling that reaches beyond the ordinary. Throughout history and into the digital age, the jellyfish remains an artistic paradox. It is ancient yet futuristic, simple yet complex, fragile yet capable of power. Its image floats through canvases, dance halls, films, and dreams, leaving behind a trail of fascination. In this way, jellyfish do not only exist in the sea, they live in our cultural consciousness, glowing softly in the shared imagination of humanity. Since the dawn of civilization, the jellyfish has drifted silently through the annals of human history, its translucent form weaving a subtle presence into the story of mankind. Long before modern science could unravel its biological mysteries, ancient cultures were already encountering this strange creature from the sea. In coastal communities where the boundary between land and ocean shaped daily life, jellyfish were not merely curiosities, they were resources, symbols, and sometimes omens. In ancient China, during the Song dynasty, meticulous records document the harvesting of jellyfish along the coast. Fishermen would gather them from shallow waters, dry them under the sun, and preserve them for consumption. Considered a delicacy, when properly prepared, jellyfish were prized for their unique texture rather than flavor. They became part of regional diets and traditional banquets, especially in the southern provinces where seafood culture flourished. These culinary practices were not casual, they reflected a deepening relationship between humans and their marine environment. Meanwhile, in Japan during the Edo period, jellyfish found a place at the tables of the elite. In a time marked by a refined aesthetic and attention to culinary detail, jellyfish dishes were served as part of multi-course meals known as kaiseki. Their shimmering appearance and gentle crunch were considered luxurious, especially when paired with vinegar or soy-based sauces. Beyond taste, they were appreciated for their visual elegance, embodying the Japanese value of beauty in simplicity and transience. But the historical presence of jellyfish extends beyond cuisine. Maritime folklore across Asia often references jellyfish in poems, paintings, and myths, sometimes as symbols of mystery, other times as warnings of danger. Sailors feared the sting of larger species, and coastal dwellers observed the timing of jellyfish blooms as part of their natural calendars. These records show that humans have long paid attention to jellyfish not only as food, but as indicators of the ocean's mood. In recent decades, jellyfish have returned to historical prominence, but for a different reason. Massive jellyfish blooms now appear in news reports and scientific journals as a sign of ecological imbalance. Climate change, overfishing, and pollution have altered the marine landscape, creating conditions in which jellyfish thrive while other species decline. Their sudden swarms are no longer just natural events, they are historical markers of a changing planet. In places like the Yellow Sea and the Mediterranean, their proliferation is recorded not in myth, but in environmental data graphs and urgent reports. Thus, the jellyfish's role in history is evolving. From a dried delicacy in ancient feasts to a luminous threat in modern ecosystems, its presence continues to shape and reflect human interaction with the sea. It is a creature that floats not only in water, but through time, its jelly-like body holding stories from the past and warnings for the future. In the shimmering shallows where sunlit waves meet the shore, a hidden danger may drift just beneath the surface. Though graceful and almost otherworldly in appearance, jellyfish can pose a serious threat to human health. Among their many forms, several species possess venom capable of delivering intense pain, paralysis, and even death. Their tentacles, lined with specialized stinging cells called cnidocytes, are not merely tools for hunting, they are natural hypodermic needles injecting a complex chemical cocktail into anything they touch. On the crowded beaches of East Asia, swimmers know well the name Nemopolyma namuri. This massive jellyfish, one of the largest in the world, can grow to over 2 meters in diameter and weigh as much as 200 kilograms. Its sting is not just painful, it can trigger severe allergic reactions, cardiovascular shock, and in rare cases, fatalities. Lifeguards in regions affected by its seasonal blooms are trained to treat stings swiftly, sometimes evacuating entire beach zones to protect the public from these drifting giants. But within the danger lies opportunity for medicine. Researchers have begun to study jellyfish venom not only as a threat, but as a key to new medical insights. The toxins they produce affect nerve cells in ways that are highly specific, opening pathways for neurological research. Scientists are decoding the molecular mechanisms behind their venom, looking for compounds that can be turned into new classes of painkillers, especially for chronic or neuropathic pain. In a world seeking alternatives to addictive opioids, jellyfish may offer a surprising and natural solution. Beyond venom, the jellyfish contributes another unexpected gift to the world of medicine and beauty: collagen. Found abundantly in its gelatinous tissues, jellyfish collagen is structurally different from that of mammals and may offer benefits in terms of bioabsorption and purity. It is being studied as a component in anti-aging creams, wound healing gels, and even surgical materials. In Japan and Korea, jellyfish extract is already used in some cosmetic formulations where its hydrating and skin-firming properties are highly valued. The paradox of the jellyfish is profound. What causes pain in the ocean may one day relieve pain on land. What appears as a simple creature may unlock complex medical breakthroughs. From emergency rooms treating sting victims to laboratories developing next-generation biomaterials, the jellyfish is leaving its mark on human health in ways both urgent and promising. As we dive deeper into its biology, we are reminded that nature's most ancient designs often hold the most advanced secrets waiting patiently beneath the waves.